In this lesson, we're going to solve radical equations using the power rule. We're also going to solve radical equations with indexes that are greater than 2, in other words, higher roots. A radical equation is an equation containing at least one radical expression whose radicand has a variable. Here are examples of radical equations. So here are the steps for solving radical equations. Step 1, isolate the radical. Make sure that the radical is on the side by itself, everybody else on the other side using the rules of equation. Step 2, apply the power rule. In other words, raise each side of the equation to a power that is the same as the index of the radical. In other words, raise each side of the equation by whatever root you're going to be dealing with. Step 3, go ahead and solve the equation for x. And then step 4, always check your proposed solution to make sure that it is indeed your solution. Now, when you're solving radical equations, one thing you have to remember is during the process, you're going to be using opposite operations to solve. And here's what I mean by opposite operations. When you square a number, such as 5 squared, that means 5 times 5, which is 25. Finding the square root of the number is the very opposite, where you take that number 25 and say what number when I multiply it twice equals 25, and that number is 5. So again, squaring a number is the opposite of finding the square root of a number. And also cubing a number is the opposite of finding the cube root of a number. So here's our first equation, radical equation that we're going to solve. Step 1 is to isolate the radical. Well, the radical sign is already isolated by itself. There are no other numbers on the side with it. So we can proceed with the next step, which is to raise both sides of the equation to the same power of the root. So in this instance, we have square root. The opposite of square root is to square a number. So let's go ahead and square both the left and the right side of the equation. So once we do that, it looks like so. That whole process that you did on the left of square root and squaring, when you do both of them at the same time, they sort of undo each other and cancel each other out, so that you no longer have the radical sign or the parentheses or the little number. The only thing that's left on the left side is just the expression of x minus 3. So you can bring that down on the left side. And on the right side, you have 4 squared. 4 squared is 4 times 4, which is 16. So we have 16 on the right side. One last step to solving this equation is to do what? That's correct. You have to add 3 to each side, and your answer x equals 19. Now that's the whole point of solving a radical equation, is you're solving for x. So my solution is 19. Well, at least we need to check and see if it's 19. That is the last step in the process, is to always check your proposed solutions. In other words, plug them back into the original equation to see if it indeed is the solution. So into the original equation, removing the x and replacing it with 19 will look like so. 19 take away 3 is 16. And the square root of 16, it is 4, so it does check out, which means yes, my solution is 19. Let's do some practice. Example 1. What is the first step I need to do here? Well, our radical is all by itself, so we don't have to worry about having to get it by itself. So the next step then would be to get rid of the radical symbol. And remember, we have to do the opposite. So since you see square root there, the opposite of square root is to square something. So let's go ahead and square both sides of the equation. That process allows you to remove everything from the left side except the numbers. So I'm going to bring down 7x minus 3. And on the right side, once you square 5, 5 squared equals 25. What's my next step to solving for x? Yes, I have to remove that negative 3, and the way to do that is to do the opposite, which is add 3 to both sides. Last step to solving this equation is to do what? Yes, I'm going to have to divide by 7. And what is x? If you said x is 4, that is correct. Now let's go ahead and check out our solution. It is always a good idea to check out your solution because not all solutions are the solution. Some solutions are extraneous solutions that we have to throw out. So you have to do that last step of checking. So since we said that x equals 4, let's plug that back into our original equation in place of x and see if it checks out. So when we do so, it looks like so. 7 times 4 equals 28. Square root of 28 minus 3. So let's do the subtraction underneath. That's going to give you 25, and square root of 25 equals 5. So yes, it does check out, which means yes indeed, 4 is my solution. Good job. Let's keep moving on. Here we have a cube root equation. So what is step 1? Step 1 is always to isolate the radical. Guess what? Someone is on the side with the radical. Who's on the side with the radical? Negative 3. So we got to get rid of negative 3. And how do we do that? We have to do the opposite. We have to add 3 to each side. So let's go ahead and do that. And now that we have the radical isolated on the side by itself as should be, we can proceed with removing the radical. And how do we remove the radical? Yes, you got it. We have to do the opposite. This is cube root. The opposite of cube root is to cube a number. So let's go ahead and cube both the left and the right side so that we can remove the radical symbol and everything that's attached with it. So on the left side, we're going to bring down 6x minus 3. And on the right side, when we multiply the number 3 times, we're going to get 27. What's my next step to solving this equation? Yes, I have to add 3 to each side. Last step to solving this equation is to do what? Yes, divide by 6 and x equals 5. Our last step now is to check out our solution and see if this is indeed our solution. Into the original equation, we're going to remove the x and replace it with 5. When we do so and do the math, you will see that it does check out that our solution indeed is 5. I will give you a moment to look over it to make sure that you see that it does check out when you plug your answer back into the original equation. Let's do another one. What's step one? Step one, yes, it should be to get that radical isolated on the side all by itself, everybody else on the other side using the rules of equation. So who has to go? Yes, that -2. Got to get rid of it. How do we do that? Yes, by adding 2 to each side. Now that we have the radical isolated all by itself, I need to remove that radical symbol. How do we do that? We do the opposite. That is square root. So we're going to have to do the opposite and square both sides. So once we square both sides, on the left side, we can bring down 2x minus 3 all by itself. And on the right side, when we multiply the number 3 2 times, we're going to get 9. What's my next step to solving this equation? Yes, you've got to add 3 to each side. Last step to solving this equation is to do what? Yes, divide by 2 and x equals, you got it, 6. Now it's time for us to check out and see if 6 is indeed our solution. Into the original equation, we're going to remove the x and replace it with 6. When we do so, you can see and examine the math there that it does check out. So our solution indeed is 6. Okay, step 1, what should I do? I heard you, yep. You said I got to get rid of that 3 that's on the left side. How do I do that? Yes, I've got to subtract 3 from each side. Now what do I do? Yep, I heard you. You said I had to square both sides because this is square root. Yes, I have to do that. So let's go ahead and square both sides. That's going to allow me to bring down 5x minus 1 on the left side. And on the right side, I have -3 times -3, which is +9. What do I do now? Yes, add 1 to each side. Last step to solving this is to do what? Yes, divide by 5 and x equals 2. So now we need to plug in our solution into the original equation to see if it checks out. So we're going to remove the x and replace it with 2. When we do so, it looks like so. 5 times 2 is 10. 10 take away 1 is 9. Square root of 9 equals 3. But 3 plus 3 does not equal 0. So it does not check out. So we have to throw that solution 2 out. It is an extraneous solution. So the answer to this particular problem is no solution. So you see here, not all solution checks out. When solving radical equations, you have to do that important last step to see if your solution is indeed your solution. I'm so proud of you. You're doing such a good job. We have one left. So what do I do first? Yes, I've got to get that radical there all by itself on the left side. So who has to go? The 3 on the left side has to go. How do I get rid of it? By subtracting 3 from each side. This is fourth root, so to get rid of the radical symbol, I'm going to have to do what? Yeah, I heard you. I'm going to have to raise both sides to the 4th power. Let's go ahead and do that. Whatever you do to one side, you do to the other. On the left side, that allows me to bring down x plus 3 all by itself. And on the right side, when I multiply the number 2 4 times, I'm going to get 16. One last step to solving this equation is to subtract 3 from each side, and x equals 13. Our last step now is to check out this solution and see if we get to keep it or do we throw it out. So into the original equation, we're going to remove the x and replace it with 13. When we do so, if you look through and see the math, you will see that it does check out. So therefore, 13 is indeed the solution to this equation. And there you have it, solving radical equations.